Hello and welcome to NavTalk. NavTalk is proudly brought to you by the NavWealth Financial Group, helping you reach your destination in life on purpose. My name is Simon Prowse and I'll be your regular host for this series of podcasts. And I look forward to bringing you interviews and content on a broad range of topics that will be educational, inspirational, informative and at times fun. So welcome everyone and welcome to our next instalment of NavTalk. Today I have the great pleasure of sitting down and speaking with Mr. Michael Katz. And Michael is going to be talking about a topic that's close to his heart, Parkinson's disease, and more specifically his foundation, the Catalyst program around raising money for research and development into Parkinson's. Welcome, Michael.
Thanks.
Or can I call you Mike?
Yes, please do.
Mike, before we get into the talk around Parkinson's, can you give us a little bit of your life story, your resume, if you like?
Sure. So I graduated from University of New South Wales in 73 or 4 and immediately took a job with a company called Charge Card Services, which was the launch company created by the Australian banks to bring credit cards to Australia. Back then, there was only American Express and Diners Club, and the Treasury had recognised that we needed a proper credit card infrastructure in this country. So they encouraged the banks who set up this joint company, and I was the 10th employee. It was terrific fun. We launched Bank Card, and I stayed there for about 2 years. But after it was launched, it became a little less exciting. So I decided to go overseas, and after a little skiing and other things, I managed to get a job at Citicorp in Geneva. And I worked there for 5 years in the capital markets area, doing Swiss franc bonds, Swiss franc convertible bonds, Swiss franc warrant. And I invented a couple of products which were quite interesting. And one of them was called a covered warrant. And this brought me to the attention of Morgan Stanley, and they hired me in 1986 to set up their Swiss office, which I did with a couple of other colleagues from Citicorp. And we launched Morgan Stanley Switzerland. That worked really well for about 4 years. And the business was very much focused on the Japanese market. We did really well until Japan fell out of bed in 1989. And so because I was regarded as an expert in Japan for some unknown reason, they sent me down to Tokyo, where I spent another 3 years, at the end of which it was time to move on. The kids were growing up, and I came back to Australia and joined the Commonwealth Bank, 1993.
And from the Commonwealth Bank, have you sort of ventured into other areas, or was it Commonwealth?
So my first job was as head of the institutional wholesale bank in the Commonwealth. I did that for about 13 years altogether, but towards the end it expanded to include some of the business bank, and I set up the Commonwealth Private Bank and also the ComSec business. That was kind of my idea. I bought that back from Morgan Stanley's equity division, and I thought the CBA was just so well positioned for a direct brokerage business that we could launch that. And there's a whole story about that, but obviously ComSec has been one of the great success stories of the Commonwealth Bank.
And bring share trading to the common man.
Exactly, and breaking the stranglehold of the traditional brokers on fees and commissions. That was the big thing to get costs down.
Wow. And you ended up, through your journey, stumbling across or strictly from circumstances, falling across this disease called Parkinson's. Can you tell us a little bit about that?
Sure.
Your journey.
Well, just to fill in the gap, I retired from Commonwealth Bank in 2006, and I did have 10 years as the chair of ING Bank, which was good fun. That ran from 2010 to 2020. And at the end of my time there, just as I was retiring from ING, my wife was unfortunately diagnosed with Parkinson's disease. And I only had the very vaguest notion of what Parkinson's disease was when she came home quite upset, saying the doctor had said she was highly likely to have Parkinson. And so we, did what everybody does nowadays. You start with a Google search, and that was a sort of oh shit moment. And we started to understand that Parkinson's is an incredibly tough disease. Basically, what it is, it's the decline of the death of critical brain cells in your brain, and it actually has a total life of about 40 years. But by the time it's diagnosed, you've usually had it for about 20 years. So it's actually quite well established. But it takes a long time for the symptoms to become sufficiently apparent that a neurologist can correctly identify that you have this disease. So we assume Frederique's had it since, the late 90s probably. It then goes for another 20 years, during which one becomes progressively more impacted because the number of brain cells that are still in existence are getting exponentially smaller. And the thing it has over 40 possible symptoms, and it's some combination of these symptoms which everybody gets, but almost everybody has a different combination of symptoms. So it's extremely difficult to diagnose, and you really do need a professional neurologist to ensure that it's not some other associated disease, but one which is perhaps less critical than Parkinson's. And, the sort of symptoms that are really common are tremor, where one hand or another will start to shake. You get a loss of sense of smell, which also comes from COVID, but in this case, it's more permanent. You can get something called REM sleep disorder, which is where you start to have incredibly vivid dreams at night, and you act out the dreams. And that's very uncomfortable because they're usually nightmares and you thrash around. So these are the sort of symptoms, but there are a range of others as well. And neurologists have a vast number of clinical ways of defining Parkinson's. By clinical, I mean that they're not scientific tests. They are clinical diagnoses where the doctor will examine you, talk to you, observe you, make you count backwards, do all this sort of stuff. And on the basis of a significant number of variables will determine that you have Parkinson's.
Mike, you mentioned your wife, Frederique.
Yes.
Frederique. How did it come about that she went and actually got a test in the first place? Was there concern, or was it just totally left field? It sounds like it was left field.
So in her case, it was a limp, a slight dragging of the foot. Mm. And she went to see the GP, and the GP sort of looked at it and said, go and see a neurologist. And so she went to the neurologist, who did the full range of testing and concluded that it was most likely to be Parkinson. You can do an MRI scan, which will determine that it's not a tumor or something like that. It's a sort of negative scan, but there are no biological tests available at this stage to determine the presence or absence of Parkinson's. There are genetic associations, but They're small. That is to say, there is no overarching Parkinson's gene. There's one gene that is significant in about 3% of Parkinson's patients. There's another one which is 4%. So there are genetic influences for sure, but there's no what we call biomarker, which you can get a blood test and say, that's for sure Parkinson. We just have not been able to develop that, or nobody's been able to develop that. So the scary thing about the disease, and which has led to our interest, is that there's really only been one major scientific innovation in Parkinson's in the last 50 years. And this was a Swedish innovation which discovered that the critical component of the neurons of the brain cells that was missing in Parkinson's disease is dopamine, which most people have heard of. And they discovered that you could give a compound orally called levodopa, and that this would substitute for the naturally produced dopamine. So 90%, 99% of Parkinson's patients are now treated with dopamine, or levodopa as it's called. This works, but only it works for 5 to 10, 15 years. But eventually the substitute synthetic levodopa is not sufficient to compensate for the missing natural dopamine that the brain has produced, and then you're in a world of pain.
So it's not a natural introduction, it's a synthetic, and obviously it can't deal with the sheer volume of the neuron.
As you're losing more neurons, you've got less and less dopamine, you have to increase the dose, and you get all sorts of side effects. So it gets ugly as the disease continues.
Understand. Mike, you mentioned that it had been in people for up to 20 years before it pokes its head out and sits on here. What sort of ages does that sort of start to come into fruition?
So the normal age range, the median age range of people diagnosed is late 50s, early 60s.
Right.
That's where the most cases. But you get early onset Parkinson's, such as Michael J. Fox, the most famous young Parkinson's patient probably. Michael J. Fox was diagnosed at 30, I believe. One of my colleagues in the Catalyst program was diagnosed at 40. That's still considered young, because if you take that from my previous statements, that means they started to get the disease in their 20s.
Yeah, right.
And so that's really sad. And it has a slightly different progression for people who are diagnosed with early onset disease.
Okay. You mentioned this innovation into Parkinson's and the levodopa. In terms of what's going on in this world and research, and it sounds like the diagnosis is one of the critical factors. What's happening in that space?
So there are a huge amount of effort going in around the world. And it's really exciting. And for me as a non-scientist, it's a privilege, absolute privilege, to meet with these super smart guys who are working away like crazy to both find biological markers that where there is some product in the blood or in the in the skin or urine or whatever, which is associated with Parkinson's distinctly. So far that hasn't happened, but that's one of the avenues of research which is extremely important and is going on in multiple research labs around the world. The second area that is being obviously researched extremely well is just the very mechanism of what is actually happening. And there are at least two major schools of thought. And please understand, I am not a neurologist, but this is just what I've acquired as listening into these conversations. There's one major school, which is that if you go back to your high school biology, if you were lucky enough to do it, every cell has something called the mitochondria in it. Mitochondria is like the battery pack for the cell. And the mitochondria in Parkinson's disease tends to be sort of failed, broken. In fact, what seems to happen is that broken mitochondria accumulate in the cell, and sort of all the rubbish, this is broken rubbish mitochondria, it accumulates in the cell, and then the brain cell eventually dies because it's got too much rubbish in it. So there's one avenue which is looking at that as a particularly important part of the development of what is Parkinson's. A second dimension of Parkinson's is inflammation. And this is, the big thing that in cell biology and biochemistry and biology today, a lot of disease is being now considered to be the subject of either inflammation or excessive antibodies being created against inflammation, and some combination thereof. So there's some superb work going on that, which we're involved in. But and there are other areas as well, but those are the two principal dimensions to what we're to the current scientific effort.
Before I ask about the we, which I assume is a bit of the program that you're involved in, just a little bit more for people out there in the understanding, and you may not know, but I'll ask anyway. In terms of the people around the world, and we've got an ageing population, sort of markers of effective, we've got 5% of the population will get it, 10%. Is there any?
So we think that the current number of diagnosed patients in Australia is about between 100 and 150,000 at the moment in Australia. And there are numbers floating around about, one every hour or something like that diagnosed. It's a little bit less than that, but it's a relatively common disease. 150,000 in a population of 25 million. And if you look at the population as only those people over 50, which is where we've got most of the cases, it's clearly quite an important.
So upwards of 1% when you really take that part of the population.
Yeah.
Yeah, okay. So it's affecting a lot of people, and this is a worldwide thing. It's not particularly prominent in Western civilization.
No. I mean, it's obviously more common in higher developed countries because of the age factor. But any country, Japan has the oldest population in the world, and it's a very big problem in Japan.
Okay. All right. So let's let us into your program and what you're involved with, and it's aptly named the Catalyst program. Can you tell us a bit about that, Mike?
Sure. So as Frederique and I began our journey of trying to understand this damn thing, we were invited to an excellent lunch by the Shake It Up Foundation. The Shake It Up Foundation was created by an entrepreneur called Clyde Campbell, who was subject to an early onset diagnosis at 40. And Clyde's a businessman here in New South Wales. He's in robotics and just an amazing man, fantastic guy. And when he was first diagnosed, as I said, in his early 40s, he said, well, this is stupid. I'm not going to lie down and let this get me. I'm going to do something about it. And he set up something called the Shake It Up Foundation. And this is the premier Parkinson's charity in Australia now. And the Shake It Up Foundation is really Clyde's creation. Clyde pays for all the administration. Every dollar that's donated to Shake It Up goes straight to research.
Wow.
And anyone who's doing any charity work, you can't run an organisation with all the tax and accounting and regulation in Australia without significant overhead costs, and Clyde just wears the whole lot. Anyway, I was very impressed. Clyde and I got together, and a third guy, Rich Ballinson, who's an American also diagnosed with Parkinson. And Rich is a super guy. He has a PhD from Harvard. He was CEO of a number of startups in the US, including a battery company that got sold to Tesla. And he also passionate. And the three of us just got together, and we're kind of the three amigos. And we found common cause. We found that we get on really well, we work together, and we fire off each other. And we had a couple of meetings, and we decided, well, damn it, we need to get some shots on goal, because since levodopa, there's not been much progress. And Clyde, Frederique, and Rich are all patients, and we want to find a cure. So we decided to set up something that would accelerate progress, and hence the name Catalyst. And this has led us to a huge amount of work and understanding about the scientific research process around the world. As it happens, Clyde had, in his search for answers, had gone to the States and basically knocked on Michael J. Fox's door. And being a persistent sort of fella, he managed to get a meeting with Michael J. Fox, and they hit it off. So there's this incredible relationship between Clyde and the Michael J. Fox Foundation, which is focused on Shake It Up being the Australian offshoot, if you will. It's not formally that, but we're definitely linked to Michael J. Fox. So just to put that in perspective, Michael J. Fox does a vast array of Parkinson's work, the Michael J. Fox Foundation. They have a budget of about $100 million a year, which is rising rapidly to $200 million. This is originally Michael J. Fox money, but now a vast array of other money coming in, including, it turns out that one of the founders of Google has a relative who might have Parkinson's, and he's throwing, serious capital at this. And in addition, once you start to peel back the onion on how medical research really works around the world, it becomes truly a fascinating case study of how the world works and how little the rest of us really know about this stuff. And it is amazing. So, for example, the US is by far and away the capital of medical research. It's just twice as big as any other country or group of countries. It's massive. And the principal reason is that there's a US government program called the National Institute of Health, or NIH. The National Institute of Health alone in the US has a budget of $46 billion a year. Okay. So nobody else comes close to spending this sort of money. Now, it's spread across cardiology, neurology, diabetes, every possible and imaginable disease and treatment that you could imagine, but it's still the biggest game in town. So medical research around the world is very focused on what's happening in the NIH and how that's working.
Do they sort of research houses apply for funding from the NIH?
Yeah,
and line
but
up?
it's mainly, it doesn't come internationally very much. It's mainly focused on US. Universities.
Yes. Yes.
And labs.
Okay.
As you'd expect.
But
totally.
They're leading the way in telling the world where they're going down research holes.
And they have public interest disclosure obligations under their legislation, which means they have to tell everybody what they're doing.
Right.
So everybody knows pretty much what's going on. The problem with this is that this has been going on for 30 or 40 years. I forget how long it is. It's a long time. And it's such a huge pool of money that it's become fairly bureaucratic in what goes on. So what that means is their process for allocating this $46 billion is very interesting. So basically, you make an application. The application is considered by a group of peers, so fellow scientists who understand the field you want to work in. And if they agree that it's a worthwhile project, it's recommended, and then it goes through a process. And basically, 18 months after you make an application, you will get a yay or nay as to whether your research project is going to be funded by the NIH. So 18 months, it actually takes about 18 months to write an application because they're incredibly complex applications. So you're looking at 3 years between the time the guy in the lab coat has the genius idea that if we did this and this, we might find a solution to XYZ health problem. And you're getting the money to start doing the research. And then the research may take 2 or 3 years. So the whole pipeline of medical research is measured almost normally in decades now. And people aren't quite realizing that. But all of this became obvious with COVID. And we set up Catalyst in the end of 20, beginning of 21. And this was right in the middle of COVID. And so the exciting part is people realized that if we waited a decade to find a vaccine for COVID using our normal solutions, we'd all be dead. Well, not all of us, but a ton of us would be dead. So, like it or not, most people probably don't like it, but President Trump kicked off a program called Warp Speed. And Warp Speed didn't get a lot of press in Australia, possibly because it was President Trump. But Warp Speed said, here's a few billion out of the 46, on top of the 46. Let's break the rules and find a way of getting a vaccine for COVID. And by God, they did it. It took, instead of 5-10 years, that we got a vaccine in a year. So this was so exciting for us because we saw this and we said, we have to do something similar. Now, we don't have President Trump's signature and a few $1 billion to throw at this. So we've got to find other ways of accelerating the research process. And that's what the Catalyst program is all about. It's looking at it and saying, we can't have these long, convoluted, bureaucratic processes. We've got to get stuff done. We've got to disrupt the normal sort of way medical research works, both we can't do anything in the US, but in Australia, we have a sort of small imitation of the US system. And we've just got to find a way. And it's partly, I think of it as a little bit similar to investment management, because if you follow the crowd in investment management, you will get the crowd return, i.e., over 20 years, you'll get an average return of 5, 6, 7, if you're really lucky, 8%. That's what you get over 20 or 30 years. You might have 5 years where you make 20, but you'll get 5 years where you lose 20, and in the middle there's 10 years where you make 8, and that's your average. This is the same story. If we the problem with the peer review process is that most of these committees of extremely smart people are unfortunately a little bit older, and they're quite set in their ways. And while they're scientific and trained to be critical, they have a tendency, as people have done for hundreds of years, to not be willing to look outside the conventional wisdom. And so the easiest way to get a grant from the National Institute of Health is to do something which is significantly similar to what everybody else is doing, but just a little bit different. And that way you'll get a grant. And the reason is the NIH is happy because they don't think you'll waste the money. They won't have a complete flop. They'll have a small result at the end, no matter how expensive your research project is, but you will, nobody will get embarrassed. And we kind of know that the people who really make a difference are the ones who are willing to take a risk, they're willing to fail, and willing to get out there and try something radically new. And, you know, Elon Musk, Steve Jobs, Google, Amazon, these are companies who had the perseverance and the imagination to say, and even Bill Gates back in the day, you know, IBM is wrong. The PC will be an important thing. From that, we got Microsoft as it is today. You know, these are examples of how in the tech space this stuff has happened. There's not a lot of that in medical research. And it's because it's a higher risk activity. You know, you don't want to be injecting people with strange substances in case they die. So you don't have quite the same liberty as designing a new iPhone. You know, that's fairly simple. Nobody's going to die unless it's basically going to electrocute them. But so medical research is higher risk. But if you want to make progress, we've got to find ways of breaking the envelope, breaking the boundaries, and looking at new stuff.
So you talk about this disruption process and breaking the boundaries and so forth. How is Catalyst going about that? I mean, and I'll come back to a couple of other questions about the relationship with Shake It Up and then the NIH, but how's Catalyst sort of breaking those boundaries? What's it doing that's...
So let me give you an example, which I think is the best example we've done so far in some ways. So in association with Michael J. Fox, there's a global program to do genetic analysis of Parkinson's patients. And the Queensland Institute of Medical Research in Brisbane had put in an application to Shake It Up and Michael J. Fox to do a test of Parkinson's patients in Australia. And we'd seen this and we said, yeah. And then they said something that was interesting, which we'd not realised and which nobody had focused on. Said, in Australia, we have the Pharmaceutical Benefits Scheme, the PBS. Now, the PBS keeps records of every prescription that is given under the PBS to an Australian resident. And guess what? If every Parkinson's patient is taking levodopa, if we know all the people, if the PBS knows all the people getting levodopa, we can actually track every patient in Australia who's probably a Parkinson's patient. And it turns out that the PBS is helpful. And with some very strict privacy controls, if you're a serious researcher, they will write to every patient receiving that medication and say, would you like to be involved in some medical research? And so we discovered that QIMR was doing exactly this. So we got very excited and we said, well, we'll get on board, we'll fund this research program. So it was $1 million research program, and we put $500,000 in, and Michael J. Fox put in $500,000. And, that's normal catalyst stuff. We're going to find any genetic links that might exist in the Australian population with Parkinson's by getting DNA samples from everybody who signs up to the research, and that'll be amazing. If we get 10 or 20,000 people who sign up, give us, we call it a spit sample. You just have to spit in a tube, send it off by post. We can analyze that, find out your DNA, keep it confidential, but then look at that DNA all the way through and say, gosh, do you realize every Parkinson's patient in Sydney happens to have this particular combination of genes? That would be amazing if that turns out to be the case.
And is it, you're finding the take-up on this type of research, because it's non-invasive, is pretty good?
Well, so this was the idea. This is where it got really interesting. QIMR had used a perfectly good PR marketing firm to help them sort of ramp up the response to these letters they were sending out through the PBS. And we looked at the marketing campaign, and as business people, we said, it's not the best marketing campaign. And we actually at Shake It Up have an in-house marketing relationship. And we said, well, we talked to them and they said, oh no, we could do a lot better job. And we said, terrific. So we went up, we rang up QIMR and we said, look, we think we should change marketing firms. Oh no, we don't want to do that. And then a day later they said, oh, we actually have a problem because the university is telling us that in order to spend $100,000 on marketing as part of this research program, we have to go through a tender process. And it's going to take 3 months. And that's going to delay the whole program by a year. We said, you have got to be kidding. But this is the sort of bureaucracy you're up against, right? So we said, okay, forget that. We will take over the marketing at Shake It Up and do it. And we'll take the $100,000 we were going to give you as a grant. We'll take that out of the $500 we were going to give you. We'll give you $400. And we'll do the marketing on your behalf. Job solved. No, university shut up. All good.
So you took control of the process and took the uni out of the equation.
Yeah.
I dare say there was a bit of fallout from that.
Oh, there was some broken noses and stuff like that. Yeah, but, the result was before we've sent out a letter, we've already got 3,000 people signed up.
Yeah. Because
we used a fantastic marketing group, and our team inside Shake It Up, we had this executive officer, Vicky Miller, who's blindingly good. And she ran this process, and we launched it back on World Parkinson's Day on the 8th of June, I think it is. And we just got Channel 7 and newspapers and everything, and it all worked. So that's an example of the sort of deblocking and breaking through barriers that we as business people can do independently of understanding the deep scientific stuff, which we don't pretend to understand.
No, you've just got the business head and make things happen. Let the scientists get on with what they do best.
Exactly. And break a few rules. That's always been I've always done that.
So let's go back to that and just a little bit of understanding around this breaking a few rules. Because obviously if you break a rule, there's a consequence or potentially, and the bureaucracy and processes would argue that the bureaucracy is there to avoid these breaking rules and people getting hurt. And warp speed was brought in. Yep. What did warp speed do that was so different in its approach by cutting out the red tape? How did it sort of break that nexus?
They did some independent research as to who was doing what in vaccines. They gave Pfizer $1 billion or some such, hefty sum of number. I forget the exact amount. They gave Moderna a lot of money and said, we want a vaccine now.
So the application and peer review process, that 18 months was chopped out.
Yeah.
And is that simply similar to what you're doing with Catalyst? You're trying to fast track the money to those scientists without going through the bureaucracy. Is that fair?
We're not there yet, because we are absolutely clear that we don't have the scientific basis to justify our own selection. We've got to have some process, and so we use a small group of people. It's actually not so small, but we have access to some highly respected people. We don't have a formal committee process, and this is part of another US initiative called Fast Grants, where they committed to getting rid of the peer review. They basically said, instead of a committee of 10, where you know the answer because it's statistical, right? If you've got a committee of 10 professors looking at a research progress, 2 will be violently against it, 2 will be violently for it, and 6 will be happy in the middle. So you just kind of know that. And, you don't actually get a lot of information out of having 10 reviewers.
Right.
So we are not trying to have a committee of 10. We want a committee. We just select 1 or 2 people on any scientific question, and we get them. And as long as nobody says this is crazy, we'll go ahead.
Yeah.
If we like the rest of the project.
Yeah.
So we give it a business sort of. We try and understand it as best we can. We then take a small group of scientific advisors to give us a sounding on it, and then we look for violent objections, and then we explore the violent objections. We actually haven't had one yet, but our thinking is if we get a violent objection to a project, that's really interesting because there's something about that. We need to understand that, and then when we get a violent objection, we'll follow it up. But as long as we don't get anything like that, as long as at least one of them says it's okay, we'll do it if we like it. Yeah. We think being prepared to fail is what it's all about. We've got to be prepared to have things that don't work.
Okay.
And we've got to tell our investors, I think of them as investors in this project, that we will have projects that don't work. Nobody after 50 years of work, it's just not the case that every new idea in Parkinson's is going to work.
So it reminds me a bit of what I'm seeing in the business world these days. It's get it up, have a crack, and quickly shut it down if it's going in a direction you don't want it to. Is that probably...
That's very much part of it, yeah.
Yeah. And being business heads, you guys are making quick decisions, or the three of you, the three amigos, as you call them, are making quick decisions in order to sort of fund that money in directly to that research.
Exactly.
Okay. Now, Catalyst, you talked about your investors, they're your group of people. It sounds like it's a very close-knit group. How does it work from that point of view with getting people in?
Basically, we've got a minimum contribution of $100,000, just because we have a very good program, I believe, of quarterly updates where we have a lunch where we bring in one of our scientific researchers who explains what they're doing. We talk about the other projects, and we need to keep it fairly tight. So Shake It Up does some wonderful work, hoovering up donations, $50, $100, $1,000. But this is because we're looking for people who are keen on seeing these changes and willing to see things done differently. Basically we're looking, 100 is the absolute minimum. We're really looking for, $1 million over 3 years is where we like to be.
Okay. So it's an offshoot of Shake It Up. Shake It Up are more the common donator. Is it are you taxed up a gift recipient?
Yes, we are, through Shake It Up.
Yeah.
Shake It Up is...
So you're riding with Shake It Up really
exactly.
hand in hand. But the Catalyst group are a separate group, very close knit. Are you finding a lot of those people have a direct experience with the disease itself? Is that why they're there?
It's either direct or family member.
Yeah. And are a lot of those people getting involved with the whole program and decisions? Is that why you're meeting regularly?
No, they're kind of leaving it to us. I must admit, I have to say, I've been retired now for nearly 20 years, and I have never been so busy in my life. This thing is sucking time away. We spend a lot of time on it, and it's fascinating because you're dealing with these scientists who are so smart. I mean, these guys are just genius, and they can explain things. The good ones are really good at it, and it's exciting to be given a window on how the neurons in your own brain work, and the detail of mitochondria and alpha-synuclein and all this other stuff. And I'm slowly understanding the cell biology. It's just fabulous. If I'd known this when I was at high school, I probably would have paid attention in Science 101. But it's fabulous. Really, really good stuff. And most people, even those with the disease, are happy to come along, learn what we're doing, but we're not actually welcoming a lot of people into the decision-making process, because we recognize that having just the three of us, we can get to a decision in 15 minutes.
Don't create bureaucracy.
If we had a committee of 10, we'd be back the same as the NIH. So we don't really want that.
I mean, in this whole thing and COVID and the way that the reaction and the fast tracking, we hope to see some changes in this whole process. But of course, a committee is going to lead to committee outcomes, right?
Yeah. And, in Australia, we have a wonderful tendency to like committees. I mean, sometimes we call them royal commissions, but by golly, there are a lot of them. And they're expensive, they're slow, I have my lawyer friends are wonderful people, but they bring a different perspective on these problems. It's not often that you get lawyers who are particularly innovative. It doesn't go hand in hand. This is about innovation and disruption. And, the people who sit on committees are not innovators.
Well, there's something there about owning a decision, and even if it's a bad one, owning a decision, right?
Exactly.
Yes. A committee, you don't own it. Everyone else does.
Yeah, collective decision-making.
So, Mike, this has been absolutely fascinating. Leave us with a little bit. You're now really close to this. You've been involved with the Michael J. Fox Foundation. You're very close to Shake It Up and more so the Catalyst. You're one of the three amigos. Where do you sit in terms of a discovery and some breakthroughs in this awkward, awful disease?
So, as I said, it's disappointing that there hasn't been anything terrific happen. There's one drug that was discovered in Queensland, has since been sold to a major European pharmaceutical company, and they're starting phase 2 trials. So clinical trials are in 3 parts. Phase 1 is safety. So is the drug going to kill someone or hurt them? Phase 2 is how well does it work? Should you take 5 milligrams or 10 milligrams twice a day, once a day, all that sort of stuff. And phase 3 is broader testing across the market to see that all of that stuff is confirmed. And for a new drug, you can do phase, and that's in humans. Before you get to humans, you've got to do biological testing. Typically, you'd like to do as much animal testing as you can, because it's as much as it's tough on the animals, it's better than humans. So there's a whole raft of work that happens first before you get to phase one, phase 2. This drug was sold to this European company for $600 million after phase 1.
Right.
They're starting phase 2. We're hoping to bring some of that phase 2 trial to Australia. This is an inflammation product as opposed to a mitochondria product. Realistically, it's 4 or 5 years away before it would be publicly available, because the phase 2 trial will take about 2 years, and then the phase 3 trial another couple of years.
Yeah.
So, but if the phase 1 trial cost about $25 million, I think, the phase 2 trial will be about 10 times that, $250 million.
Yeah. Okay.
So even phase 2 in a major drug is something that has to be done by a global pharmaceutical company, because no small company has $250 million to throw around.
Yeah, well, they've got a profit motive, I assume, as well, right?
Well, everybody's got a profit motive.
Very small R&D when it comes to the outcomes.
Yeah,
they get it
I mean,
right.
the pharmaceuticals have changed. They used to do all their own research in-house. They discovered that the committee problem was so big in-house that they weren't finding the good drugs. Right. So most of them don't do a lot of phase 1 testing anymore. They rely on startups, and then they'll buy for $600 million or $300 million or whatever. And the original scientists will make quite a nice amount of money. That's fine. They have to put in the big bucks, but they also watch the big bucks to make sure that they're investing in something that, with the fullness of time, will give them a return.
Yeah.
Typically you think today that to get a new drug on the market, you are looking at a couple of $1 billion.
Wow.
And people don't realise that. They sort of, we should give away the patents and all this stuff. Yeah. It's $2 billion of expense to get a new drug into the market.
Yeah.
And somebody's got to pay that. And it's got to be earned back by sales of the drug. So that kind of general philosophy is also interesting from someone coming from a non-pharmaceutical background.
Well, there's your business case, right?
Yeah, exactly.
One last question, and then we'll probably look to wrap up. In terms of the world and their research, how much is shared, and how much? I'm assuming when it goes to pharmaceutical companies, it's cloak and dagger and held very closely. But in terms of these research fellows around the world, and the NIH, and they're leading the way, the US, are we sharing the data, and are we sharing the information to try and get to the answer quicker?
Yes. The beauty of the patent system is that you can share the data if you have rights to the drug. So if you've got a patent and it's a solid patent, you're perfectly willing to tell the world about how the drug works. Okay. As long as nobody can steal it from you.
Right. So it provides a platform to share.
It's the patent system which is the backbone of this. Right. Now, it has its issues, and there are all sorts of people who will argue this up, down and sideways, and less developed countries, and we shouldn't have patents, they're terrible. But it's only the existence of patents that's allowed us to make the medical breakthroughs we've had in the last 100 years.
Right. Fantastic.
I'm a firm believer in private enterprise, and it's this desire to make money which drives these people to work 100-hour weeks, in the lab till all hours, tinkering with these dangerous products, trying to get them to work. These people work an amazing amount of time. It's not an easy life. And it's extraordinary stuff. So hats off to them. And if they're lucky enough and smart enough to find a solution, then they should be paid a mozza, as we say in this country.
Yeah.
That's
the way it works, right?
It's the way it should work. It must work. So I'm very comfortable with that. And we're very comfortable to try and help some of the better scientists to get there.
Yeah. Well, Mike, this has been fascinating. Look, I'd like to thank you for sharing and giving me your time to have a talk today on a topic that's very close to your heart.
Well, I'd like to thank you for the opportunity because, as you said, it's very close to my heart, but I do believe it's interesting, it's exciting. It shows that retirement is not the end of the world. Everybody can be involved in things like this, and it's important to do so. There's stuff to be done everywhere, and those of us who are lucky enough to be in a position to help have to put our shoulders to the wheel. Just because we're a little older doesn't mean we're dead.
Great point indeed. Well, Mike, I wish you all the best, and Clyde and Richard also in your pursuits. I've got this feeling that we're going to be hearing about you with some wonderful discovery through your Catalyst group, and look, fingers and toes crossed.
Well, thank you. We hope so.
Thank you, sir. Thanks for joining us today for NavTalk. You can listen to other podcasts in the NavTalk series via YouTube or where you get your favourite podcasts, or simply search NavTalk. Be sure to follow NavWealth on LinkedIn, Instagram, Facebook or Twitter. And please, if there are any particular topics you would like us to cover for a future episode, let us know via our website. I'm Simon Prowse. Until we talk again.